So we have a problem from 3-6 that we need to finish up. Okay. So I have to factor first because I need to see if my denominator cancels. So if the denominator does not cancel, then that means there's an asymptote here. But if it does cancel, that means there's a pole. So I have to factor the numerator first. And now, you probably don't remember how to factor difference of cubes. That's okay. You don't have to have it memorized for your test. I will walk you through it here. Okay. So, 8x cubed is a cubed. So a is 2x. And b is 1. Okay, that's for difference of cubes. So it is 2x minus 1. Okay. And then I do a squared. So 2x squared is 4x squared. And then I do plus ab. Even though there's a negative there, it is plus here. So plus 2 to x times 1, which is 2x. And then b squared, which is plus 1. Okay, so that's how that factors. Like I said, you don't have to have that memorized. And then that's over 2x minus 1. So does that cancel? Does the denominator cancel? The only way is if you know how to factor difference of cubes. Okay, you could because it cancels, like if you did divide those, you would end up with this because it cancels. So in this case, like doing long division would work, or synthetic division with the 0. Okay. So those cancel. So that means the function that I'm graphing is 4x squared plus 2x plus 1. What type of function is that? It's quadratic. So what's the graph look like? Yep, it's a parabola. And since it's canceled, what type of discontinuity is that? A hole. So our two types of discontinuities are asymptotes and holes. And so here, because it canceled, there is a hole. Okay, so I can go ahead and say, now that there's none, because I'm looking, this is the function I'm graphing. It's a parabola with a hole. So there's not a horizontal or vertical asymptote, but there will be a hole, and that will be where x is equal to positive 1/2. Okay, because x can't equal 1/2, so that means there's either an asymptote or a hole. So, because it canceled, I give us a hole. So, to find the whole location, you know x is 1/2, plug it back into your simplified function. So call the simplified one g of x, just so it's something a little different than f of x. It does. Yep, you get 3. So 1/2, 3. That is where the hole will be. Okay, but I need to know how to graph that first. Let's go ahead and do the rest of this where it says the x-intercepts and the y-intercepts. Okay. Well, the x-intercept, so that's the zeros of the numerator. So you can go back to the original if you want. should be looking at what the simplified. We want to look at the simplified one because I've canceled out that 2x minus 1. So x-intercepts are where 4x squared plus 2x plus 1 equals 0. The 2x minus 1 canceled. So I would factor that first if I could. That's what I want to do is factor. But this one does not factor. You can't have factors of 4 and 1 that are going to give me 2. Like 2 and 2, that's going to give me 4. 1 and 4, that's going to give me 5. That's not going to be able to add a 2. So we need to use quadratic formula. And yes, you have to know quadratic formula for your test. So you should have that memorized. So opposite of b is negative 2 plus or minus b squared minus 4ac all over 2a. So just calculate what's under the radical first. So I'm going to be doing 4 minus 16. So the biggest thing that I want to take from that is that it's negative. So it's negative 12. But because it's negative under the radical, what does that mean? Yeah, there's I. It's imaginary. So is that an x-intercept? No. So there are none. Okay, y-intercept. So plug 0 in for x. And again, let's call our simplified one g, just so it's something different than f. And when you have a quadratic or any polynomial in standard form, remember your y-intercept is just the constant because all of these others will be 0. 0, 1. Okay.
Is there any specific reason why we're using a simplified version rather than, would it give you the same answer anyway? Yeah. Or what would it do there?
Yeah, this one would. But here for your x-intercepts, when you're looking at a cubic, it's going to be different than the quadratic. And so the 2x minus 1 is not actually part of your graph because it cancels. And so all it is it just affects my domain. It tells me that I'm going to have a hole right here. And so that's why I had to do the simplified version for the x-intercepts. Okay. Because otherwise you would solve that and you would get solutions for x, and there's not x-intercepts. Like when you actually graph it, you'll be able to tell that it doesn't cross x. So after you simplify, you can just use the simplified version. Just don't forget that it has a hole. All right, so we can do our domain if you want now, or you can do it at the end. We know that x, it's the denominator. So domain is something where you have to look at your original. Because x can't equal 1/2. So, but it can be anything else. You could wait until you have it graphed to do this too, if that helps you, if you're better at domain after the graph. But we should be able to do it without, because we've done domain of rationals for, a few months now. We look at the denominator, and that's how we do the domain. Okay, let's graph what we have, and then we're going to have to find another have any asymptotes. So right now, the only thing showing up on my graph is this y-intercept at 0, 1. Okay. And I know that there's a hole at 1/2, 3. What type of graph is this again? It's a parabola. It's quadratic. So what's the most important point of a parabola? The vertex. Do I have the vertex? I don't know. I don't know that that's the vertex. It's not actually, but just because you have a point below this one, or you have it, doesn't mean one of those is the vertex. You don't know if you have it or not. So that's what we have to find to graph 4x squared plus 2x plus 1. So we're graphing 4x squared plus 2x plus 1. And I need to find the vertex. Okay, so to find the vertex when it's in standard form, we have that little formula, opposite of b over 2a. That's another thing you're going to need to know for your test. You're also going to have to know the completing the square one, the b over 2 squared. So those are very similar. They're not the same, but they're similar, and you have to know which one goes with what. So when you want to find the vertex, it's opposite of b over 2a. So that's negative 2 over 2 times 4, negative 2 over 8, okay, negative 1/4. Plug that back in so you can find the y coordinate. So negative 1/4 squared, or g of negative 1/4 is 4 times negative 1/4 squared plus 2 times negative 1/4 plus 1. We should get 3/4. So my vertex is negative 1/4 3/4. Okay. So I'm going to graph that point. And then remember, quadratics, parabolas always have an axis of symmetry. So I am going to do that. Okay, so negative 1/4 is 3/4. It's really close to that point. All right, I'm going to draw the axis of symmetry, but I need to label that's what it is so we know it's not a asymptote. Because we've just been doing a lot of graphs where we have dashed vertical lines, and those are asymptotes. But for parabolas, just to help me graph it, they have an axis of symmetry. So that's the when would you use the b over 2 squared? So you use the b over 2 squared when you want to complete the square. You'd want to complete the square if the directions told you to write this in vertex form. So it's changing a quadratic from standard form to vertex form. That's something we did back in 3.1. So it's been a while. And but it is on your test. It's on your quiz. It's also on your test. That's for completing the square. Yeah. B over 2 quantity squared.
Okay, that makes more sense.
But we'll talk about that when we start reviewing for your test. I just wanted to point out like that it's not the same thing as this first one. Okay. Okay, so what I can do is I can match these points now on the other side of this line of symmetry. But it's kind of hard because you're at 1/4 here, so this is 1/4 and this is 0. So I'm 1/4 of a unit away on the right, so I go 1/4 of a unit away on the left. So it's a little hard to draw. Even though there's a hole here, this still represents a point, so I can match it on the other side. And when I match it on the other side, it is not a hole because you only have one place that x can't equal. This is just helping me to graph though. So the hole is at 1/2. So here I'm at 1/4. So I go 1/4 and a half. So that's 3/4. I'm 3/4 away on the right. So if I go 3/4 away on the left, I'm already at 1/4. If I go 3/4, then that gets me at exactly -1. You can plug in points though. If the axis of symmetry and the counting over with the fractions is too hard, just plug in points into your function to help you find points. Okay, now we can graph. I need to make sure that stays helpful. Alright, so what it was, what we talked about at the beginning, was a parabola with a hole in it. Questions about that?
The whole location.
Yes.
You said something about it at the beginning. How do you know if you're going to have a hole? Is it because it's a parabola?
No, because it cancels. The denominator cancels. So I know that because there's a denominator with an x, that I either am going to have a hole or an asymptote. I have something. If it cancels, it's a hole. If it does not, then there would be a vertical asymptote here. Because I know from the beginning that x can't equal 1/2. So there's something there, either a hole or an asymptote. Good question. Any other questions? Yeah.
How come you would have a close hole? They just no asymptotes altogether.
Because this is my function is this.
So you don't have anything at the top, so you don't.
Right. Right.
Okay.
So with a parabola, you don't have any asymptotes. Okay. All right. So let's do a word problem. What? Oh, no, not for rationals. Okay. So notice that it says that okay, C of P is the cost per 10,000. So whenever I find C of P, I know that that's a multiple of 10,000. So I'm gonna have to add 4 zeros to the end of whatever I find. Okay. And then P percent. So P is already in percents. So when I go down here in part A, and it says find the cost to distribute bins to 25%, 50%, and 75%. So those are P. And P is in percent, so I'm just going to be plugging in 25, not 0.25. I don't need to change it because it says P is in percent. So the first problem, I'm just plugging in 25, and then 50, and then 75 for P. So go ahead and calculate it, and then we'll talk about changing it so it's in 10,000. When you calculate this, because you need those to subtract first, use parentheses there in your denominator.
Excuse me, Miss Cecil, could you send Carmen McKay check out at attendance?
Yes?
Thank you.
Okay. So when you calculate the 25, what do you get? $73.3, is that what you got? And it's 0.3 repeating, right? So in this case, because I have to move my decimal, I am going to do this. I'm going to put the line so I can make this more accurate. Because I'm not going to just add 5 zeros, or 4 zeros. I'm going to go over 4 places, but for this one, I'm going to fill it with 3s because it's 3 repeating. Okay. The others don't sound as bad. What did you get for this one? For 50. 220. Okay, what about for 75? Okay, 660. Good. So comment on the results. So 25% cost. Okay, so here's what I mean. 10,000. These are in 10,000. So that's 4 zeros. That's 4 decimal places. 1, 2, 3, 4. So I'm going to fill these because it's 3 repeating with 3s. Okay, so that's 1, 2, 3, 4, 5 total. So it's a closer approximation now. So 733,333, and then 0.33333. But we're okay for now.
How did you get to 700?
Because the cost is in 10,000. So I moved over 4 places. So I'm going to do the same thing here, but since these were exact, I'm just going to be adding 4 zeros to the end of it. Okay, so 50% cost. $2,200,000, and 75% cost. $6,600,000. Okay, so when I go to graph this, I'm just going to graph the first quadrant because I'm not going to have a negative percent, and then I'm not going to have a negative cost. So I'm just going to use the first quadrant. So my x is p, so p percent of the population. So I need to go to for x? We're talking about percent. Well, but if I think about past that, 100. Okay, so the max percent I'm going to have is 100. So I'll call this 100. So halfway is 50, so I'm going to be counting by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay. And then this is my cost. And I'm going to do this in millions because then it becomes a little bit easier to graph. So like I'm going to call this 1, so that's 1 million. Okay, 2, 3, 4, here's 5, 6, 7, 8, 9, 10. So I'm counting by 500,000. Alright, so this was my function here, was this. I have a vertical asymptote where? What can't P equal? What would give me 0? 100, okay. If I have 0%, I have $0. Okay, if I had 25%, it was 73,000. 25. Okay, 50% was 2.2. 75, 65 was 6.6. Okay, so this is what my graph looks like. So the main thing I want to point out is that asymptote, because this says here, what happens if the city attempts to give recycling bins to 100% of the population? Okay, so the closer you get to 100%, so as P goes to 100%, C of P, what does your graph do? Where does it go? Yep, which is, like if you think about domain, or in this case range, I'm going up to infinity, positive infinity. Right, that's what I'm saying. But it's impossible to get to 100%.
Joey,